Because chemical bonds involve the electromagnetic force, an electric current can be used to drive a chemical reaction that wouldn't happen on its own. This method of controlling chemical reactions is called electrolysis. In this demonstration, I'll use electrolysis to separate water molecules into hydrogen and oxygen gas, then recombine them in a fiery explosion to form water again. These stainless steel wires are going to serve as electrodes, the parts of the electrical circuit that make contact with the water. Pure water doesn't conduct electricity very well, so I'm going to use sodium sulfate as an electrolyte. That's a substance that will dissolve in the water and allow electricity to flow more easily. There are other kinds of electrolytes I could use, for example sodium chloride or table salt, but table salt would be a dangerous choice because the electrolysis reaction would separate the salt into sodium and poisonous chlorine gas, and I definitely don't want any of that to come bubbling out of the solution. Now I'm going to connect the electrodes to a direct current power supply, an old computer cable that I modified slightly. And as soon as I plug it in, you'll begin to see bubbles forming around the two stainless steel wires that I'm using as electrodes. Hydrogen gas is bubbling up from the negatively charged electrode called the cathode, it's the wire on your right, and oxygen gas is bubbling up around the positively charged electrode called the anode on your left. You can see there's about twice as much hydrogen as oxygen bubbling out. That's because there are two hydrogen atoms but only one oxygen atom in each molecule of water. Some of the oxygen is also reacting with iron in the positively charged anode, causing it to rust, and that rust is starting to discolor the water. These so-called stainless steel wires obviously aren't stainless anymore, and by the end of this demonstration, most of the anode will have rusted away. It takes a long time for the balloon to inflate, so I'm just going to fast forward the video here. Now, the electric current is starting to warm up the water, so to keep it from getting too hot, I'm going to set this container into a bucket of cold water. When I first tried this experiment at home, the water got so hot it boiled over, and I don't want that to happen again. Okay, I'm going to fast forward the video once more. In real time, it takes about an hour to fill the balloon. Alright, finally the balloon has been inflated with a mixture of hydrogen and oxygen gas. Now, hydrogen gas is explosively flammable, as you'll see in a moment. But when hydrogen burns, that is, when it reacts with oxygen, the result is just water. It won't be liquid water, of course. The explosion will be much, much hotter than the boiling point, so the water will form as very hot steam, and all you'll see is a flash of fire. Okay, here goes.